All right, for your lesson this evening, you guys are going to watch this video. When you come to class tomorrow, we'll go over the lesson in class and you'll have time to work on it. Our goal for today is to compare measurements before and after translations, rotations, and reflections. For this first activity, we're measuring segments, so go ahead for each question. The unit is represented by the large tick mark with whole numbers. So you're going to find the length of each of these segments. Please pause the video right now so that you can complete each of these problems. For the first measure, you get 4 5/8. For number 2, you would have, and don't forget your units. For number 2, you would have 4.7 units. And for number 3, it is 3 3/4 units, or 3 6/8 units if you did not simplify. And for number 4, we don't know exact, but it looks like the hardest problem was probably number 4 because there wasn't an exact measurement to go off of. If you didn't get exactly the same answers as Mrs. Kaloran did, that's okay. But start to look at how the ruler looks because we're going to be measuring segments. For this next problem, we're going to translate polygon A, so point P goes to point Q. Write the length of each side in grid units next to the side. You can see that we moved point P onto point Q, and we moved each of them 5 units, and then when you're done, you're going to make sure and put all of your side measurements on each of your sides. Next, we're going to rotate triangle B 90 degrees clockwise using R as the center of rotation. We need to write the measure of each angle in its interior when we are done. Patty paper would be my best recommendation for this activity, and then you can just follow along with the picture I'm drawing. Hopefully it looks the same as yours. I started this operation by first highlighting and putting a center on point R, and then highlighting its side segment and showing you the 90-degree turn that's going to be happening. So you can see that the segment that's rotating is right here, and we're going to rotate it 90 degrees onto this other segment. It should be the same length, so I'm going to extend it to be the same length. Once we're there, we're going to draw our side. And once that's drawn, then we're going to find out where our length is for our next angle, and you can see I'm making it 30 degrees right there and finishing off my triangle. I've highlighted the 30 degrees green, which means my triangle's 30-degree angle should be corresponding, and there is my 90-degree corresponding angle in the same location on a different figure, and my 60-degree corresponding angle is there as well. In this next image, we're going to combine the sides and the angles. So you're going to reflect pentagon C across line L. Remember, we always need a line when we're reflecting. In your image, you're going to write the length of each side in grid units next to the side. You may need to make your own ruler with tracing paper or a blank index card. In the image, write the measure of each angle in the interior. Okay, so you may need to use your protractor to make sure that your angles are exact. Okay, so I'm going to start this by measuring 1 unit away from the line of reflection, which means our other side should have 1 unit away from the line of reflection. Then I have included my angles, so you can see there's 150 degrees on both of my figures, my pre-image and my image, all my red 90-degree angles, and then my green 120-degree angles. Remember, these are corresponding angles. So my object didn't change, and all of these measurements remain the same. Next, I'm going to start labeling each of my side lengths. So I know for sure these are 2 and 3, and then these are kind of halfway in between, so I use my ruler to measure 1.8, 2.4, and 2.4. And then that should be the same on the opposite side for my corresponding sides, so the ones that are in the same location from the pre-image to the image. Please remember that when I say ruler, I mean an index card or patty paper that I've measured units on, because we're still going by units. We're not going by inches or centimeters. When we get into the lesson synthesis, what is a rigid transformation? You guys need to understand that the rigid transformations are when our objects are not changing size or shape. So our angles all remain the same and our side lengths all remain the same, and all of them are corresponding to one another. How do you know when one shape is not the image of another under a rigid transformation? Well, did it change size or did it change shape? If it did, then it is not considered a rigid transformation. Remember, all of our translations, reflections, and rotations remain the same size and shape, which declares them as rigid transformations. What are some good ways? Oh, we talked about that. What are the 3 basic types of rigid transformations? Your answer was already given. By the end of the day tomorrow, you should be able to describe the effects of a rigid transformation on the lengths and angles in a polygon. We'll see you in the morning or the afternoon.